In this video segment, we're going to talk about how to use the product rule to take the derivative of a product of two functions of x. So first, I will just write out the rule. It's very simple. I'm going to use u and v to represent my two functions of x, just so I can write it in sort of a simple form. I know a lot of textbooks have really formal versions written in them, but I'm just going to write a simple version. So the derivative of the product of two functions u and v equals u prime v, the derivative of u times v, plus v prime u. Very simple formula. All you have to do is remember it. Let's do some examples to see how it works. Okay, so I have an example here. I have the formula written up in the top corner here, so I can reference it if I need to. The first thing I'm going to do is I'm going to identify one of my functions as u and the other of my functions as v. So let's call this part u and this part v. Okay, now it is simply a matter of looking at my formula and taking the derivative. So h prime of x, the derivative of h of x, equals, so my formula says u prime v. The derivative of u is 32x cubed minus 5 times v, exactly as it's written. I'm not going to do anything to the v. 3x squared plus 2. Plus, now I'm on to the second part of my formula, v prime u. The derivative of v is 6x plus 0, because the derivative of 2 is 0, times u exactly as it's written, 8x to the fourth minus 5x. All right, so let me just label what everything is here. This is u prime, this is v, and then I have plus, this is v prime, and this is u. So those are all of the parts of the formula. If you weren't asked to simplify, you could just stop here, but I know if you're in my class, I'm going to ask you to simplify, combine your like terms, and if it's possible to factor any common terms out. So first I will FOIL this. So I'm going to do first, outside, inside, last, and then I will multiply the 6x into the last binomial. Okay, when I multiply everything out, what do I get? When I FOIL, I get 96x to the fifth plus 64x, oops, that should be an x to the fifth. Let's fix that, there we go. Plus 64x cubed minus 15x squared minus 10. And now when I multiply out v prime u, I'm going to get plus 48x to the fifth minus 30x squared. And you can see that I do, in fact, have some like terms here. I have x to the fifth here and x to the fifth here. And then I have x squared here and x squared here. So let's just combine those, and I'm going to get h prime of x equals 144x to the fifth plus 64x cubed minus 45x squared minus 10. And there are no like terms that can be factored out of this answer, so that is my final answer. Okay, let's do one more example. So we have another example here. K of m equals m to the 1/3 times 3m squared minus 4m plus 1. And again, I have my formula written up in the top right corner. The first thing I'm going to do is identify what is u and what is v in my product. So this is, I'm going to call that u, and I'm going to call the second part V. So that is my product, U times V. So here we go, filling into the formula. K prime of M equals the derivative of U, which is 1/3 M to the negative 2/3, times V, 3M squared minus 4M plus 1, plus the derivative of V, that's going to be 6M minus 4, times U, or M to the 1/3. So again, let me write out what everything is. This is U prime, V, and then we have plus V prime U. Okay, I'm going to clean this up. I'm going to simplify, multiply everything out, and then simplify. So when I multiply things out, I'm going to multiply this in here, and then I'm going to multiply this out here, and then I will combine my like terms. Oops, forgot some parentheses there. So we have K prime of M equals, okay, I'm going to get 1M to the 4/3 minus 4/3 M to the 1/3, 4/3 M to the 1/3, and then plus 1/3 M to the negative 2/3. That's the first part, the U prime V. And now over here at this end, the V prime U, I'm going to get 6M to the 4/3 minus 4M to the 1/3. And so let's look for those like terms. This I can combine with this. And what else do we have? We have this can be combined with this. Okay, so K prime of M equals 7M to the 4/3 minus 16/3 M to the 1/3 and then plus 1/3 M to the negative 2/3. And I know if you're in my class, I like you to get rid of all of your negative exponents in your final answer. So I would like this answer written as K prime of M equals 7M to the 4/3 minus 16M to the 1/3 over 3. I should make that look more like an exponent. 1/3 up there. Okay? And then plus 1/3 M to the negative 2/3, and I'm going to put that M to the negative 2/3 in the bottom as M to the 2/3. So this would be my final answer. There we go. All right, good review of the product rule.